Okay, so if we take a look at this, argon has atomic number, argon is in column 8A, which means it has 8 valence electrons. So I draw 8 right here. 1, 2, 3, 4, 5, 6, 7, 8. Good. Magnesium is in 2A, which means I only draw 2 electrons connected to magnesium. Phosphorus is in 5A, so I need to draw 5 of these. 1, 2, 3, 4, 5. So just for symmetry purpose, there we go. And bromine is in 7A, which means I draw 8 dots around bromine. I'm sorry, not 8, 7. So 6, 7. And these are the electron dot structures for the following elements. So let's take a look at noble gases. Like we said before, noble gases are always stable. And if we take a look at the configurations, we can see why. So we're going to do these quickly by using our periodic tables. Neon is in row 2 at the very end. So I get 1s2, 2s2, 2p6. And if I add it 2, 4, 10, that is the atomic number of neon. If I do argon, I get 1s2, 2s2, 2p6, 3s2, and 3p6. Right? And if I do krypton, I do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. So as you can see, both the s orbitals and the p orbitals are filled. But why is that important? Think about ionization energy and electronegativity. If my orbitals are filled in the highest energy level, do these electrons need to be taken away? Can they be stolen by another atom? Well, no, because they're filled, and so they have enough people to support them, or electrons, I should say. At the same time, if they're already filled, are they looking for electrons? So when I talk about electronegativity, are they looking for more electrons to fill up their orbitals? Well, no, because they're already filled. So this is a key factor as to why all these noble gases are actually stable. So they follow this rule called the octet rule. If my s orbital is filled, that gives me 2 electrons. If my p orbital is filled, that gives me 8 electrons, which means I am now at the octet rule. I already have these 8 electrons that give me the configuration of a noble gas. It's called octet because like an octopus, I have 8 legs or 8 pieces, which are our electrons. Our next section will go into this right here. But atoms of metals tend to lose their valence electrons so that they can move down lower to a filled orbital. However, atoms of nonmetals, so everything on the right side of the periodic table, will try to gain electrons so it's closer to a noble gas. And we will go into this when we start talking about ionic bonding. So what I actually want you guys to do is the first part of your exit slip. Exit slip. We are in chapter 7.1. So on page 193, like you to complete numbers 3, 4, 7, and 8. 3, 4, 7, and, oops, not 8, but 8, sorry. And this is due at the end of class. So give me a quick idea of the valence electrons as well as how these electron configurations are done. After this, we'll learn about cations and anions. Good luck.